we're given that x equals t squared plus 1 and y is equal to 4t cubed plus 3, where t is between -1 and 0. We want to find the arc length of this. So recall the arc length formula is the integral from a to b, square root 1 plus the derivative of y with respect to x squared, and then dt. So first, let's find the derivative of y with respect to x. That's just going to be dy over dt over dx over dt. Now, y is just 4t cubed plus 3. So if I take the derivative, it's 12t squared. X is t squared plus 1. So the derivative of that is 2t. Simplify, I get 6t. So I can plug that into dy over dx. The limits I'm going to use are -1 to 0, because that's what we're given. And then we have 1 plus 6t squared dt. Let's distribute the exponent to the 6 and the 2 to get 36t squared dt. And at this point, we have to evaluate this integral. It doesn't look pretty, but we have to use trig substitution. So we'll let t equal 1/6 tangent theta. So then dt is 1/6 secant squared theta, d theta. So I can plug that in now. So instead of t, I'm going to have 1/6 tangent, and the square root of that. Multiply that by dt will be 1/6 secant squared d theta. And because these depend on theta, I'm not going to use the limits -1 to 0. So for now, let's leave it as it is. We'll worry about the limits after we integrate. Okay. So now let's simplify. I can pull out the 1/6 outside. I have 1/6 tangent squared would just be 1 over 36 tangent squared. And then what remains is secant squared. So the 36 is going to cancel. I'm left with 1 plus tangent squared. And then outside is secant squared. Okay. Now, 1 plus tangent squared is a trig identity, which is just secant squared. And then I have secant squared outside. The square root of secant squared is secant. So this whole thing is secant. And when I multiply that by secant squared, I do get secant cubed. So I was able to simplify the integral down to 1/6 secant cubed. Unfortunately, there's still a lot of work left. So what I'm going to do is break this up as secant times secant squared. And I'm going to use integration by parts. So the u will be secant theta. The derivative of secant is secant tangent. dv is just the remaining secant squared d theta. And v is tangent. Okay, so now I have 1/6 integral of secant cubed is equal to the integration by parts, which is uv minus integral v du. So that will be secant tangent squared d theta. So I'm just going to leave the 1/6 here, secant cubed d theta. And I'm going to make a substitution now. We did say that 1 plus tangent squared is secant squared. So tangent squared is just secant squared minus 1. And I did make a mistake here. I should have kept the 1/6. Okay. So there's a very common mistake. You have to include the 1/6 because it's outside. Integration by parts is only the inside of the integral. So I'm going to distribute now the 1/6 to both pieces. Okay. All right, now we can simplify this further. So the secant times secant squared is secant cubed. And then we have secant times 1. So at this step, I'm going to add this integral 1/6 secant cubed to the other side. So we'll have 1/3 now, secant cubed d theta. Because you have two copies of 1/6 integral secant cubed. And then we're going to have this negative and negative remaining. That'll be positive. 1/6 still. That's out here. Integral secant theta d theta. So I'm only going to work on the right. We want to integrate secant theta. This one, if you don't have memorized, the way to derive it is to multiply top and bottom by secant plus tangent, and then do a u substitution. So the u substitution will be the secant plus tangent. And so you'll basically end up with du over u, which is ln of u. Okay, and then u is just secant plus tangent. So I briefly mentioned how to do it. I don't want to go through all the details. Now I did forget to put the 1/6 over here. Okay, so don't forget to include your factors. Okay, so I wanted 1/6 integral secant cubed theta d theta. Because remember, up here, it was 1/6 integral secant cubed d theta. So I want to multiply both sides by 1/2 to get 1/6 secant cubed d theta. So that would be 1/12 secant tangent plus 1/12 ln secant plus tangent. Okay. So now we have to recall that we let t equal 1/6 tangent theta. So that means tangent theta was 6t, or you can think of it as 6t over 1. So if I draw a right triangle, this is theta. Tangent is opposite over adjacent, opposite being 6t, adjacent being 1. Do the Pythagorean theorem. We get 1 plus 6t squared, which is just 36t squared. I can plug in secant now. Secant is just hypotenuse over adjacent. So that would just be square root 1 plus 36t squared. And then tangent is 6t, we said, plus 1/12, and then plug in again what secant and tangent are. And C I'm going to ignore, because now we have the limits from -1 to 0. So if I plug in 0 here, everything's going to be 0 because this factor is going to be 0, multiplied by the rest is 0. I have ln of 1 is 0, plus 6 times 0 is 0. So ln of 1 is 0. Yeah, so it's just 0. And then minus, plug in -1. I have 1/12 square root 37 times -6 plus 1/12 ln root 37 minus 6. So I can distribute out the negative. Negative 1/12 root 37 times -6. And I'm going to distribute the negative over here, which will be minus 1/12 ln root 37 minus 6. And here we have negative 1/12, negative 6. That's 6 over 12, which is positive 1/2. Root 37 minus 1/12 ln root 37 minus 6. And here, because root 37 is greater than 6, you don't need the absolute values. So we'll just put parentheses. So this is our arc length.